We're going to talk about acid-base imbalances. Accurate analysis of blood gas results is vital to making appropriate treatment decisions. The need for respiratory support and use of medication to correct acid-base imbalances are often based upon the results of the blood gas. Normal ABG values are presented on the screen. The pH is 7.35 to 7.45. Anything below 7.35 is acidotic, and above 7.45 is considered alkalotic. Your PaCO2, it should be between 35 and 45 in the normal blood gas. PaO2 for arterial blood samples should be 80 to 95. Your normal bicarb rate is 22 to 26, and a normal oxygen saturation is 95 to 99%. Your base excess is considered normal at plus or -1. What is the pH and what can it tell us? The pH is the measure of acidity or alkalinity of the blood. If the pH is less than 7.35, this indicates a buildup of acid or loss of base. On the opposite side of the acid-base balance, the pH is greater than 7.45. This indicates a loss of acid or a buildup of base. The base excess is a calculated figure which provides an estimate of metabolic component of the acid-base balance. The next step is to determine the primary cause. There are two causes for an acid-base imbalance, either respiratory or metabolic. The PaCO2, which is the arterial CO2 content, represents the carbon dioxide, which is an acid and can only be removed through the work of the lungs. Therefore, the PaCO2 represents the respiratory component of acid-base balance. If carbon dioxide is not effectively removed through gas exchange in the lungs, acid will build up in the blood and the pH will decrease. If the lungs are working overtime or gases exchanged has improved, then the PaCO2 decreases, which is a loss of acid. Therefore, you have a pH that will increase. The response to acid-base imbalance by the lungs is rapid. Bicarbonate, which is the base and represents the work of the kidneys. Bicarbonate is excreted by the kidneys, and this is much slower than the work of the lungs. Bicarb represents the metabolic component of acid-base balance. If there is a loss of base, then the deficit will cause an acidosis. If there is a buildup of base, then alkalosis will occur. Facts to remember when the primary problem is respiratory. The pH and PaCO2 move in opposite directions. Therefore, if the pH goes down, the CO2 goes up, or vice versa. For each increase of 10 millimeters of mercury in the PaCO2, the pH will decrease by 0.08 units. For each decrease of 10 millimeters of mercury in the PaCO2, the pH will increase 0.08 units. Other interesting facts to remember when the primary problem is metabolic. The pH, bicarb, and the PaCO2 will all move in the same direction. Compensation will be respiratory driven. Another tool that can be used is shown here. This is the acid-base alignment nanogram. Using the following 5 rules will assist with ABG interpretation. Rule number 1, think of CO2 as an acid, and it reflects the respiratory component of acid-base balance. Rule number 2, think of bicarb as a base, and know that it reflects the metabolic component of the acid-base balance. Rule number 3, when the primary problem is on the respiratory side, the metabolic side will adjust to compensate, and vice versa to normalize the pH. Normalization of the pH is the ultimate goal. Rule number 4, if the pH is normal, then the blood gas is normal or compensated. And if the pH is not normal, then the blood gas is uncompensated. To use the nanogram, you simply plot the pH, PaCO2, and bicarb from the gas, and if the pH falls in the red, it is acidosis, and if it falls in the green, it is alkalosis. Utilizing the PaCO2 and bicarb, the primary cause can be determined.